So thank you very much, and thanks to the VMSG for inviting me. I'll try not to speak. I tend to speak very fast, so I'll try not to speak very fast. But the talk I'm giving today is not kind of very science. It's more because of who I'm speaking to. And the point is, I'm going to deal with two things. I'm going to deal with how we, as the agency that responds for monitoring volcanoes and earthquakes in the Eastern Caribbean, in Caribbean particularly, how we deal with the challenges and the strategies we have for dealing with them. And then I'll spend some time looking at the recent eruption in St. Vincent, which was also very interesting. So, of course, I start, and my slide is not advancing for some reason. Yeah, it's not. It wasn't on the screen. Yes, that's the point. Right, so it should open. No? Yeah. Well, actually, the slide that's there is actually I'll just advance this. I'm gonna talk about, first of all, the setting. And the question of whether or not, I had a question mark behind the paradise when I had the slide first. And the area that we live in, this is a picture of the northern part of St. Vincent. You're standing facing north. You're looking at the villages of Chateau Belair and Fitzhughes. And in the background, you have La Soufrière volcano, which erupted in 2020, 2021. And this kind of tells you why people, to a large extent, come to these parts to live. You have these, I don't like the pointer thing. You have these, and I'm not ignoring you guys over there, right? You have this lovely bay, which means that if you're settling the area, so that's why the French first came to St. Vincent, that's why it's Chateau Belair, city with good air. While the British came after, Fitzhughes, that's a very British name. So, it's nice, lovely area to anchor out. There's gently sloping land in the volcanic small island states. You have sloping land, gentle flat land is a priority, so you don't have very much of these. So where you have them, you have settlements. You have steep mountains, you have rainfall, you have the potential for hydroelectric power, you have fertile land, agriculture, you have rocks, which you could have quarries. So there's a quarry behind here, there's a hydro plant up here, and there's people living here. That's why people go and live there, But then you have a volcano that erupts every now and then. And often they forget that. So in the Caribbean is one of the most hazardous regions in the world. It's said to be second. We spend a lot of money in dealing with hazards. The statistics, they tell you about 2/3 of the world's disasters that affect small states happen in the Caribbean. The geologic setting, while beautiful, is quite challenging. And there's a particular uniqueness about volcanic small island states that they're small and they have all the issues to do with small island states. But because they are volcanic, it means that there are landscapes where you have loose material. And if you're in the tropics, that loose material moves down slope whenever rain falls. So they have issues. And if you live and work here, if you want to do research here, you have to bear in mind the fundamental issues that they live with quite apart from the volcano. The volcano is kind of in the background there. And because of what they have to deal with, they have to deal with all these things. In the region, we have these, what I call risky mountains. You have the area I'm speaking about extends from the Los Angeles Island Arc. It extends all the way from Sombrero up there, up in the north, all the way down to Grenada. It's an island arc from subduction zone, subduction mechanism. You have 21 volcanoes. We're responsible, the agency I'm talking about is responsible for monitoring the volcanoes that are in the territories that were once British colonies. The islands of Guadeloupe and Martinique, they are managed by the IPGP, the Institut de Physique du Globe de Paris. And further north in Saban and Staffshire and St. Martin further north, the Dutch are responsible for that, although we were involved. The point is that you have these volcanoes that are fairly young. They've had periods when they're either erupting or they've had severe earthquake swarms. They have rocks that are quite young. They have fumaroles associated with them, or they have all of the above. They're small and people live on them, and they have essentially volcanoes that can erupt. And even when the volcanoes are not erupting, they can have kinds of activities that can be quite concerning. You could feel earthquakes, and the earthquakes get people agitated. And because of that, you have to have, and in fact, if you want to, there's a review that was done recently on the island arc system and all the work. There's lots of work, research that has been done in the region. If you want to read up on it, there are lots of publications around. The point is that if you look at, say, a place like Dominica, these are dates of events, seismic swarms, earthquakes, periods when the earthquakes were shaking the ground so much that the people got concerned. There might have been periods when you had failed eruptions. You could see the amount of them. In Dominica, you have had quite a few, because Dominica have quite a few earthquakes that volcanoes that can erupt. St. Kitts, you've had the 1980s, Supre, volcanic center in St. Lucia. You probably have known about Montserrat, Supre Hills. In fact, Montserrat earthquake swarms go back to the 30s. That's just the most recent one since seismic is around. Nevis Peak and St. Vincent's La Supre. The point is these are very active systems, but they don't erupt very frequently. The rate of subduction is quite slow, so the rate at which you have, the frequency at which you have earthquakes, volcanic eruptions are not so much. So the agency that monitors it is Seismic Research Center, where I've been associated with. And we are slightly different than the typical sort of observatory, in the sense that we are not just responsible for volcano monitoring, but we're responsible for dealing with earthquakes. We also contribute towards the tsunami warning system in the region. So we will set up one of the last and probably most positive contribution of our UK partners in the old days was to establish seismic in the 1950s. Interesting thing is that seismic was established in the 50s, about 40 years after the French had gotten the message from the 1902 eruption that you need to have volcano monitoring in the region. Took you folks a little bit, your ancestors, a little bit longer to get the message, but you did. So we're responsible for providing warnings and outreach, well, warnings to people. We have gotten that, I'll speak about that later on. I'll speak about how we got into outreach, and we do some level of postgraduate teaching. So we're responsible for the islands of St. Kitts, Nevis, Antigua, Barbuda, Montserrat, Dominica, all the way down to Grenada. And we either provide a service in terms of volcano monitoring service on the islands that do not have volcanoes and have large earthquakes. We deal with seismicity. So that is setting where we operate in multi-hazard framework. The fact that we have some challenging times, we have volcanoes and we have the agency. What I'm going to go into now is look at how we have dealt with some of these challenges and some of the strategies that we've used. So the next slide looks at the evolution of our network. The core of the monitoring at seismic started in the 50s with a seismic network. And the first kind of instruments were these analog stations, this Wilmore photographic seismometer. Anybody who's a seismologist here would know. In those days, we used to have a single instrument in the island that would record the earthquake on a photographic record, and there would be an operator in the island who would then process that record and send it on the banana or the boat to Trinidad, where we were based. Of course, that was a problem between the 50s and sort of the 70s. That was a problem because it meant that, you know, events could be happening. You didn't know until a few months after, when the boat arrived, that it actually happened. So over time, this analog network, which was essentially based on transmission of a seismic signal from a particular collecting point using radio waves to Trinidad eventually, it developed from being standalone on the islands to being such that as the technology developed, you were able to use radio waves to basically hop it along the islands and get it to Trinidad. So one of the strategies that was used earlier on during this period was actually moving with technology. There's a feedback or some sort. I'm hearing something, hear myself. So during this analog period here, really the focus was on bringing seismic signal from the islands to Trinidad and using the technology as it developed. During that period, we had the 71 eruption of St. Vincent, 71, 72, a lava dome came up, lake boiled. Lena spoke about my experience with that. And then in 79, Supre erupted. And again, the next thing that we did, as we realized that we really needed to get the data to Trinidad faster. We moved from standalone, we moved to radio waves to hop it along. But the other thing that was challenging in those days is that the software for processing the earthquakes it was such that it was difficult to locate events in the kind of arc. Remember, we have this arc. We have a seismic network that is essentially a linear feature. And therefore, what they had to do at Seismic is develop their own software to enable. There's a feedback or something.
Yes. Whoever's online and is typing, can you mute yourself, please?
And please don't put videos because you're disturbing the
We should be on this.
you know.
Yeah.
Okay.
Right. So yeah. So yeah, I was wondering what it was. I thought it was one you that making noise. Yeah. So yeah, this is really low tech. So the thing was that the first strategy was to try to use the technology to get the data to us faster. And then the next thing was that because of the fact that the software didn't allow you to locate events properly because of the linear nature of the network, they developed in-house their own software processing, earthquake data processing, acquisition and processing system that catered for the configuration of the arc such that you could locate earthquakes. So by the time the 79 eruption happened, in fact, around this time, you had an in-house system called the SUPRE system. Of course, it was called a SUPRE system mainly because even then, Seismic was particularly interested in SUPRE. A SUPRE system that allowed them to process earthquakes. And that was kind of, in terms of this period, that was the main thing that happened. One of the things that the SUPRE eruption did was to allow them to then propose to, I think it was UNDP, a project which allowed them to kick forward that development. So the SUPRE system up until 79 was not quite developed. They got some funding here, which is the first first major place where you then access external funding to finalize the SUPRE system. In those days, they were still using 286, and I don't think anybody knows here about what a 286 computer is and 286 and that kind of thing. That was a big jump forward when they did that. And that made a big difference. So then when you got to 1980, you know, then began to transition the system from one that is just analog to one that is more digital. And the next big jump was the 95 eruption in Montserrat. Montserrat erupted in 95, and one of the most significant thing that it did is that, again, it brought resources to the region to put into monitoring earthquakes. And one of the things that was big in Montserrat in the early days, that's when broadband instruments became a big thing. Before Montserrat, you were mainly using single component instruments to monitor earthquakes. Montserrat showed that broadband, I think it was a big deal. And we also learned from that because we were involved. We then got into putting in broadband instruments. And broadband instruments meant we required you to get more into digital, digitizing the signal at the source and getting it to you in a digital format. The next big thing, and as you notice, there's not very much happening until you sort of get closer to the digital period. The next big thing that made a difference was the Sumatran event in 2004. Don't know if anybody, well, some people might have been very young then. In 2004, there's a huge tsunami, earthquake and tsunami that happened. What that did is that globally, that made the entire world's concerned about tsunamis, including our part of the region. And one of the challenges that you had when you were working at Seismic in those days, that if you talk to any prime minister in the region, they didn't think about volcanoes, or they didn't think about the fact that a big earthquake could happen. All they wanted to know was what you're doing about tsunami monitoring. And tsunamis don't happen very often in the region. They hardly happen in the region. But because it had happened, they got fixated on that. And I remember by then I was the head of Seismic, and then I remember having a conversation with the Prime Minister of Trinidad once about that, and trying to make the argument that really you shouldn't be worried about tsunamis, you should be worried about earthquakes. I didn't really win the argument. So what we then did at Seismic is that we changed strategy, and we thought that, okay, you want a tsunami monitoring system, maybe we could capitalize on that. And therefore we proposed to the US aid itself a major project. We decided that we were going to use now satellite technology, get a lot of instruments that were very broadband, and put them in and establish what we call a tsunami, sort of a tsunami monitoring network for earthquakes. And that allowed us to get funding from US aid to put in what we call a VSAT network, a network that allowed us on each island to have very broadband three-component instrument collocated with continuous GPS and with accelerometers also that allowed us to basically increase the dynamic range of the seismic signal we could collect, as well as get into monitoring ground deformation. And we were able to put 5 islands. And then, you know, in that case, the IPGP and the French saw that, you know, what we had put in was a good idea, and they partnered with us. They got their own money to put in another set of stations, and we got between sort of this event happening and this period here, by the middle part, by the sort of 2009, 2010, we had moved from having 0 sort of VSAT stations, 0 stations that these stations were set up such that they could stand alone in the islands. They had redundant power supply. They were set up that if earthquakes, big earthquakes happen, or if hurricanes came in, they could survive that. They could survive on their own for quite a long time. From 0, we then had, we brought in 5 with the French, we brought in another 10. So we now have a West Indies network that basically have stations in all the islands. We'll eventually get to that, where we have, in fact, 1 or more than 1 strong motion instrument, broadband instrument, as well as continuous GPS. That was sending then now the signals in real time to Trinidad. So you really moved from something which was not quite real time to something that was real time. And then it just continued. As you see, we partnered with colleagues in the US to put in what they call a network of, a global network of, well, a Caribbean network of continuous GPS stations. And that meant that we had more continuous GPS. So we ended up over time to have a fully digital network where now we have multiple stations in each island. The diagrams in the left, you probably can't see them. It's just showing you how the configuration changed. We changed from essentially a situation where we would bounce in these stations between the islands using radio waves. Then we got release circuit telephone line until we now have independent stations up in the island sending it in real time. And essentially that's how, through a system of sort of making use of events that happened, as well as making use of the change in technology, we have been able to enhance the network such that now we have 52 seismic stations with at least 1 continuous GPS station in the island. In fact, and you have access to a lot more stations now because you have a virtual network where we share data with others. So our network has expanded without us actually happening to go to the governments to get the funding. A lot of it came from grant funding from external sources. And that's an example of how we sort of utilize the opportunities that existed or came about and develop the network. The other major thing that we did over the years is to get into education and outreach. And this is kind of a timeline that shows you how it developed. And the key things is in the early days when seismic started, the only person that spoke about anything to do with earthquakes and anything to do with seismic was the person who was in charge. And traditionally, if you had to hear anything about what was happening in volcanoes, you had to speak to the head. And that moved from a situation where in 79, the volcano in St. Vincent erupted, and they realized that probably the message wasn't getting there. So they organized in 1998 a special seminar in Trinidad called the Lester Antilles Volcanic Awareness Seminar. And that was our first major attempt to sensitize the people who were involved in disaster management in the region about earthquakes and volcanoes. One of the interesting things about that one is that one of the concerns then was the fact that Montserrat we were having seismic events in Montserrat. And the person who came from Montserrat actually chastised the seismic people for the fact that they were making all of this. They were so concerned about Montserrat, and the comment was that they're not going to retard the development of Montserrat because of the volcano. In 1998, they were telling them that. And then the Montserrat eruption happened in 1995. And one of the key things from 95 eruption that we as an agency learned is that up until that time, I think the scientists thought that they were doing a fairly good job with telling people what was happening with earthquakes and with volcanoes. You realize in 95 that they weren't. Because if you had gone to Montserrat in 95 and spoken to most people on the ground, first of all, some of them didn't even know they had a volcano. They didn't know about a volcano that could erupt. So they were totally surprised when the volcano erupted. And we, in turn, who were monitoring the volcano, we were totally surprised that they were surprised because we thought it was obvious and we thought that we were doing a very good job. So then we kind of have to have a major rethink, and we kind of had a big decision. We thought strategically, and we thought that what we needed to do is get more into that. And one of the first things that we did, we got again funding from externally to develop a project where we essentially hired an educational professional to work with us to develop materials, to go up the islands, to tell people about the fact that they have volcanoes that can erupt. And when we realized that it actually worked quite well, we then convinced the university, because seismic agencies like Seismic Research Center don't get into too much outreach. We monitor the volcanoes, we do research, and that's it. You know, keep your head, that's your line. We don't get into sort of educational outreach. But when we realized that this works so well, we then convinced the university that we would make that position, we'd create a position at Seismic where somebody was employed specifically to do that. And that then pushed us towards doing outreach more. One of the interesting things that happened in this project, is that one of the first parts of the project was a workshop in which we brought all the disaster managers to Trinidad, and we told them about the earthquakes. And one of the comments that they made was that they needed to have a document that kind of summarized the state of volcanic hazards in the region. And I don't know if you know about something that's called the Volcanic Hazard Atlas of the Los Angeles. That's the genesis of that idea of doing that book. Essentially, we decided that what we were going to do is collaborate with various people who are working on volcanic hazards in the region and come up with a document, a book, a reference book that will tell you about volcanic hazards. And if you're working in the region and volcanoes, that's kind of your first stop to tell you anything about volcanoes in the region. It's still relevant now. That book would eventually published. Again, you know, we don't have funding to do this routinely, so we have to find sources to publish the book. And one of the things that we did with the book is that we got funding to do the book such that we could then give away most of it. So we give away multiple copies of the book up and on the islands. What the book also did is that it meant that we now have a resource material for ourselves to use for outreach. So that book then became the basis upon which we could then produce more materials that was then used. But then going forward, there's a research project that came along. Dave in the back there was involved in this, strengthening resilience in volcanic areas, which I think in terms of research projects that we collaborated was to a large extent very transformative in terms of how we interacted and how we did even outreach. Because Trevor did a lot of work in terms of science, understanding models of pyroclastic flows, of lahars and different things. But one of the key things I did is that it got us involved in what I call community engagement, speaking to people directly in the communities about volcanoes and working with them, you know, this whole thing about citizen science and all that. And that kind of set off a number of things. And we continue to build on that. But that was a key thing in terms of quite apart from research, in terms of getting us into working at a community level. One of the useful things that came out was a creation of some short films where we went to St. Vincent and we interviewed people about their experience in the 79 eruption, and we documented what their experience was during that 79 eruption, which they had never done before. And therefore, we got into not only the publication, the preparation of materials like pamphlets and books and things like that, but also the creation of audiovisual materials. So that's the first kind of films that we got into as a result of this Trevor project. And then the next key, that then led sort of more than close to 10 years after to something that's called the Volcano Ready Communities Project. That's kind of where we were just before the 2021 eruption. This was a project where we got a chance now as scientists to work in 12 communities in St. Vincent. Directly, we went to the community and we spoke about them, about the volcanic hazard. We developed hazard maps and various other things. That actually was very useful prior to the eruption, because the eruption in St. Vincent happened in 2021. By that time that happened, it meant that we had been in St. Vincent over 2 years working with the people who were most affected by the volcano. So that when the eruption happened and we started speaking to them, it meant that there was a lot of trust in terms of what we were saying and what we were doing. So in summary, some of the challenges that we have in the region is in terms of funding. And one of the reasons which we do it is by one of the strategies is by getting grants to build our capacity, by developing partnerships to do research, and by using the opportunities like events, natural hazard events that happen. We have logistic challenges in the fact that you have to move a signal through all these islands. We make sure that we have enough stations on the network so that the instruments could still, so in monitoring for the location of earthquakes, you really just need about three three seismometers, 3 or 4. But what we would do is put in more than that, so that when they break, we will still have a minimum amount. So there's redundancy in the network. And we also try to build local capacity, use the technology. In terms of we have long repose period between eruptions. People forget about the eruptions, forget about the fact that they can erupt. So we do use education outreach and engage with communities. And you know, these are some other strategies that we use. So despite the fact that we have these challenges, we could use these different techniques that we have over the years to still ensure that we continue to do what we're doing and ensure that we could have a community that is engaged and ready for dealing with it. So I think the last thing I'm going to talk about is the fact that Soufrière volcano erupted in 2021. And I think in that, it kind of allowed us to put all these things together and in fact benefit from them. I'm just saying that if you want to read, this publication, the papers in that are open access, so you could access them and learn about what happened in this eruption. I'll first start by the fact that even before the eruption happened in Simmons, there was a number of things that had happened that helped in terms of managing the eruption. It relates to all that outreach story I spoke about. Before the eruption, we had worked with the government to update their volcanic emergency plan. In fact, this map here that you have here had been modified. The volcanic hazard map, as it said, had been updated. And the main modification was the fact that the red zone had sort of expanded to take up the entire northern part of the country, because logistically, the areas just to the north are we estimate, of similar risk to exposure from volcanic activity as the areas here. So orange, there was a little bit of orange up to the north, but logistically that didn't make sense for the disaster managers, because if you have to move people away from the volcano, you kind of have another area to the north that's safer, would have sent a wrong signal. Instead of moving to the south, they would have all run to that area up there, which didn't make sense. So we made it all red. The point is that there were a number of things that we did before. There was actually in 2019, there was an actual physical exercise in Tennessee where they went through the simulation of an eruption, a large-scale exercise where it was part of something that is called Trade Winds, which is a U.S. military exercise where they work with our security forces in the region to develop logistics. But one of the things that they did that year was to simulate an eruption. They worked with us on an eruption scenario, and the disaster managers actually simulated evacuating people. And in fact, that affected how they responded, because what they discovered is that if you try to evacuate people along this part of the island, it's very difficult because of the coastal processes there. So they then decided that they could do evacuation by sea on this side, but on this side, it has to be by land. And all of that came out from the exercises. So there was a lot of things that happened before, and there was some that happened during. I'll speak about them as I go through. And some of these are some of the things that actually happened during, you know. Before I go through the eruptions, one of the most interesting things was this drive-through, volcano awareness drive-through, where they went, because remember, this is during COVID times, so you can't bring people for a meeting. You have to go to people to the meeting. So how they did was this innovative way where they went, similar to if you were, well, in the Caribbean, they have a way of if you have an election coming, there's a way in which the politicians will go with a loudspeaker in a car and go to areas and tell people basically vote for me. Well, we kind of did something like that. We won't tell them to vote for us. We tell them this is what the volcano is doing, right? And this is a way in which you reach people. To me, that was personally a very interesting way of doing it. So for those of you who have heard about the eruption, you could probably just leave this part, but I'm going to go to what happened in the eruption now, right? And please excuse that face there. I didn't do the graphic. I wouldn't have that face up there if it was me. But the point is that the eruption started very quietly. Soufrière is one of the systems that we look at very closely. So by the time you got to December 2020, unfortunately, remember, this is in the midst of COVID. The network in St. Vincent had gotten really decimated because of various things. We couldn't physically go to the island to fix things. So by the time the eruption started, you had one seismic station operational, really, the one here in Belmont, which is where the observatory is based. So maybe that's why we didn't see as much earthquakes as we did before. Maybe not. I think there really wasn't that much earthquake. So the first thing we learned about the eruption or about something happening was the fact that one of our colleagues who's based in Montserrat, he subscribes to this NASA. NASA has this hotspot monitoring, remote monitoring system where they look for fires globally. And he identified a hotspot on Supre. Now, when he told us Supre is not supposed to have heat source that you will see from satellite. So we got concerned. And that at the same time that was happening, within the space of a few hours or so, somebody in St. Vincent who lived and who could see the volcano every day started to send on Facebook the fact that he was seeing steaming from the mountain. Again, A, you're not supposed to see a hotspot, and B, the volcano is not supposed to be steaming, that you could physically see it steaming from the side. So therefore, one of the things that we did, we contacted the local unit. There's a local unit there, super monitoring unit. And we told the guys, you need to go and see what's happening. So they climbed up the volcano and they looked in and they then called us. I remember speaking to them. So they're up on the mountain, they called us. And they're telling me they're seeing this black mass. And then they sent me a picture. They said, the volcano is erupting. You guys need to get back off the hill, first of all. And we need to speak to the government because so all of this is happening, and we hadn't seen very much seismicity. We hadn't, in fact, they had, during that same December, there had been some earthquakes, and we had gotten concerned by the earthquakes, and we had told them to go and visit the mountain to check. And they hadn't seen anything. They sent pictures, there was not change. But by that time when they went up, the 27th, I think they went up on the 28th or the 29th, they had verified that there was an eruption. And again, our response mechanism is such that one of the first things that we then do is we contact the government and we then brief them about what we think was happening. And again, our response is to tell them, A, that clearly an eruption was ongoing, an increase of eruption. And B, because of the nature of the network, one of the first things we have to do is put more instruments in. And that was a challenge because, of course, at that point in time, Trinidad and Tobago, where we were, was locked down. They had stopped flights. St. Vincent had never really stopped any flights. I think the government was always very open. You could come or go as much as you want. But the problem is that we couldn't get out. So one of the things that the Prime Minister had to do was contact his Prime Minister in Trinidad and allow us to come up. And then we had the problem of how do we get up? There was no aircraft running at the time. Fortunately, again, we were able to get assistance from the regional security system. They had a plane that was going about the islands in connection with COVID. They used to carry samples up and down the islands for testing at the time. So we got onto the plane. And of course, we're not normally that fortunate when we move about the islands. We don't have our own plane to move, right? But then we had our own plane and we made full use of that. So we filled the plane with as much equipment as we can. And we went to St. Vincent. And at the same time, one of the things that happened, again, because of the relationship we had, as soon after briefing the cabinet directly, we virtually went live on the radio on St. Vincent and told people what was happening. Again, the government was we had built up a relationship over the years, and they were okay with us telling people really what was happening and how we respond. So we got there and we put stations in, and we spent the next week or so just basically, and if you're ever in a volcano observatory, if you ever have to deal with an eruption, those first parts are very intense. You sleep as much as you can, and you just work nonstop. Of course, our challenge again was that, remember, COVID, so we had to be quarantined. So we moved from Trinidad to St. Vincent, and we weren't allowed to interact with anybody for the first week or two of our quarantine. So we were limited in terms of the amount of support we had. Therefore, we had to work even faster. But we were fortunate by the end of January, we were virtually, we had a network that was quite similar to that, where we had put in 5 or 6 stations. We had 8 stations, I think. And I don't think we had by then put in any GPS stations yet. I think the GPS stations went in by February. And of course, as soon as one of the things that you learn with monitoring and with earthquakes is that as soon as you put in a seismometer, you start getting earthquakes, right? I mean, just to see nature of things. So therefore, we did detect earthquakes, but the events that we quickly realized we were detecting was actually the growth of the dome itself. We weren't really having any deep earthquakes. We weren't having what seismologists would say a real earthquake. We were having earthquakes related to the process of the growth of a dome, a mass of rock that then built up. We were able again through connections with the regional agency, which we had built up, to get support. The government were able to get support to do aerial surveillance. So we were able to fly over and take pictures of the dome and things like that. And again, because we have connections with Montserrat, we were able to involve our colleagues in Montserrat in assisting with the monitoring. One of the things that we didn't have capacity in was gas monitoring, and also monitoring the growth of the dome. So we got 2 colleagues to come and they assisted in that regard. And then one of the first things that we needed to do was to get a sample of this dome. So this mass of rock, the crater is 1.5 kilometers, and there is a pre-existing 79 dome in it. And next to it, where you have that yellow dot, is where a new dome was coming in. It's 1.5 kilometers. To get to the dome, naturally, you have to climb on a rope about 100 meters. So we had a challenge. The dome is growing and we need to get a piece of it. Fortunately, again, we got support from the helicopter, and then on the 16th of January, we got a sample of this 2021 dome, which to this day, I think is the only sample that exists of that 2021 dome, because subsequent to that, it was destroyed. But the dome grew, and it grew from being a dome in a classic way to being more like a lenticular, I think it's called a coulis, that wrapped around the pre-existing dome. And that went on for some time. And the earthquakes that you had was really dome building related earthquakes. But then in March, we started to get some real VTs, and we got what we call a volcanic tectonic earthquake swarm that was beneath the volcano. Again, another interesting anecdote about that is that at the time that event happened, we were actually physically in the volcano. So we had a team deploying things in the volcano. And just to share some light humor, but I was physically in the volcano at the time, right? And we were landing a helicopter, landing some material lower down below the crater. Then we were physically taking them up and carrying them to the summit because we want to put in a new multi-gas, right? So I'm carrying this equipment. I'm close to the top, right? So the guys down the bottom, they get the radio from the observatory that these events are happening, and they start telling me, waving to me to come down, and I'm just waving to them. I put this stuff down and came back down and realized that they were telling me to come down here, and we had to leave. But we left, and the swarm died out, and we were able to subsequently go back. So the first major event was this VT swarm. This is kind of how this is a helicopter of the drums, and it went quiet. So that was the first major indication that something was changing in the system. We always thought that the dome can grow. It could either, the scenario we told the government was that it could either keep on growing, ad infinitum, but we really thought that at some point it could go explosive. And this was kind of the first indication that it can. And again, the way in which we operated is that as soon as this happened, we would have then briefed the cabinet in St. Vincent and told them that was happening. At the time, the Prime Minister wasn't actually on island. So his deputy was standing in. But the next thing that happened was, of 2 weeks or so after, earthquakes picked up again. We got another VT swarm, and this time the swarm was even more intense. It was bigger events. They were stronger. They were more strongly felt. One interesting thing about the island is that the people on the west coast can see the volcano. Those on the east coast are on the volcano, but they can't really see it. So the ones on the east coast, even though they are on the volcano, they weren't really so much engaged with an eruption going on until they started to feel the earthquakes. Before that, they couldn't see the mountain steaming, while those on the west, who are further away, could see it. So that's interesting in terms of your perspective and how you respond. So the events went on, and then they moved from the 5th to the 8th into a period where you started to have these banded tremor, and the tremors got very similar in frequency and signature. We then had what we call harmonic tremor going on. And again, that was the next thing that told us that things were really ramping up. And we then got to a stage during this day that we felt that we didn't have any clear indication that something was going to change anymore. The signals had gotten to the stage where we didn't expect any more change before it went explosive. And we then briefed again the government and decided to evacuate people. And fortunately for us, well, fortunately in the sense that we got it right. At 8:41 the next morning, you had an event starting. And this basically drums get saturated. And that's the first explosion that you had. It exploded early in the morning, and then they had another explosion late around just after midday. And well, yeah, 2:45, and then 6:30 you had another one. And when it started, really, the way in which it started, Soufrière is famous for these sort of volcanic explosions that go up to 8, 10 kilometers, very discreet, single bang, goes up, then it quiet. And how it started was like that. And we were very comfortable, but you know, it's doing what we expect. And then from 6:30, it just never stopped. It just went at 6:30 and just continued gushing ash for the next 24 hours. And we then got a bit concerned that it had gone from a stage where it was these sustained batches of events to where you had so much ash happening that it could then compromise things. Even though people by then had been evacuated, evacuation, as the note said, evacuation order had been called, and they had evacuated people by the night. Most people were out. Fortunately, it did not continue the sustained explosions. But by the 11th, we had information from, again, there was a lot of, in this eruption, there was a lot of collaboration between the people on the ground, the seismic team, and external collaborators. And one of the things that we got assistance from was remote sensing. And we found out from, I think, this image by Raphael Trampin, who I think is a Pleiades image or something like that, that he got that indicated that there was a crater that had been formed on the morning of the 10th. And there was no an existing explosion crater. The period of intense adventing that went on in 24 was quietly changed, and then you began to have discrete explosions again. The explosions then became further and further apart. We then began to have pyroclastic flows on, I think, the 11th or 12th. As the explosions became less intense, I guess the thinking was that the plumes were not as vigorous enough to sustain the column, and you started to have pyroclastic flows by column collapse. And by the 12th and the 13th, you started to have these, when you had an explosion, a discrete explosion, you often had pyroclastic flows. And that went on until the 24th, I think 22nd was the last explosion. Yeah. But you had in total about 32 or 34 explosions, depending on how you look at them. And the effect was that, you know, it basically dumped a lot of ash in the island. One of the things that happened shortly after was the problem with pyroclastic flows. The result is that you had a crater that looked like that originally before 79. So you had a dome in the middle, you had a pre-existing crater, this is a little crater on the side, as an 1812 crater that existed before. Basically, the dome grew in this area, and then an explosion formed the crater around that area. So you have here now, as the explosion crater that you have there now, this is a picture from world, as the same lake here, as there, and that's the pre-existing crater around here. So the configuration of the top of the mountain has changed completely. You now have no longer a pre-existing dome. Essentially, a lot of the material here, there's a lot of tephra that was ejected during the explosion phase that essentially covered the dome. So the dome is buried somewhere underneath here. All of the 2020, 2021 dome has gone, as far as we can see. And a substantial amount of the 79 dome has also been destroyed, or else is buried by tephra. One of the interesting things that happened, we think, is that when you had column collapse, in addition to the collapses often going on Laracai, there were actually materials. So some of these material inside here, inside the crater itself, actually pyroclastic density currents that actually just collapsed and hit the wall back here and just settle in here. And that's why you have so much Teflon. That's just a summary of the plot of the eruption. In fact, particularly showing you how the alert level went from green to orange during the period when you had the dome growth to red. One of the interesting things about the alert level system is that how it was set up. In fact, once the eruption started, they should have gone to red, because the alert level says that once the eruption is ongoing, it should go to red, or it should be at red. But one of the problems is that the kind of eruption that you had, which the alert level didn't cater for, meant that you really didn't need to be at red, because red means that you have to evacuate people. And that's just a summary plot. So in summary, some of the things that we learned in terms of the eruption, apart from putting everything together, is the value of pre-eruption planning. The fact that we had done so much work in terms of preparing and engaging with people in St. Vincent, they had plans in place, that made a huge difference. The fact that we had done so much work on the island and understood the volcano in a way in which we could sort of make a very good estimate of what it would do made a big difference. So pre-existing research, pre-existing work on the volcano is very important. And the fact that we had a nice team and a lot of partnerships, we had a lot of research collaborators that helped both nationally and internationally. That made a big difference. You know, being able to get external support is very important. Having a multi-parametric data set, not just earthquakes alone. One of the things that happened, remember I said seismicity wasn't saying very much for a long time. And actually monitoring gas and the ground deformation made a difference. So you can't just depend on one technique. The fact that we were able to, I didn't mention it a lot, but one of the key things with this eruption was actually ongoing engagement of people. There's a lot of PR, public relations, outreach, a lot of materials. A lot of the materials that we did for the Volcano Ready project was used during the eruption. And one of the things that was interesting also is the fact that during an eruption, during an event, you have to evolve the evacuation plans. There was a point at which during the eruption, because we weren't sure that we could actually detect when an explosion was going to happen, they started to modify their plans to cater for the fact that, okay, their plans originally was predicated on us giving them 24 hours warning. That was how their plans were set up, the emergency plans. So we gave them 24 hours warning, they evacuate people. But we got to a stage where we weren't sure we could give them 24-hour warning. So therefore, during the course, before we actually did give them warning, they were in the process of planning for not getting a warning. And just the first thing that happens was an explosion. How do they react? So you have to evolve your plans depending on what the volcano is doing at the time. You can't just depend on what it is. And then it's useful to have people who have some experience. And my final slide, I think I've gone too long, is just sort of to summarize what I was speaking about before. The fact that partnerships, collaborations, one of the things generally I'll say is that people in volcano observatories, often we're not unique in the fact that we operate in a resource-constrained environment. We often are overworked, understaffed, under-resourced. And therefore, it's a challenge to do what we need to do, but it's also a challenge to work with people like yourselves who are interested in research. And I think if you want to do, I think it's important to do research like that because you could extend, as we have shown you, we could extend what we understand about the systems. But I think when you're doing research with institutions like that, you have to bear in mind some of these challenges that they have, and therefore you have to approach them in a way in which they benefit as well as you benefit from what they have to do. And if you use those opportunities, it will work. We were very strategic in terms of deciding ourselves. We want to move in a particular direction, do a particular thing. I think that made a difference. We were clear in our priorities, what we wanted to do, how we wanted to get things done. We knew that the key thing for us is to be able to detect an event happening before it happens so that people can get out of the way. And that was key in terms of determining what we did in terms of collaborations, what collaborations we went in. You have to ensure that your monitoring is covered, that you have a basic monitoring that you can detect what's going to happen before it happens. You have to work with the disaster management agencies. That's very important. And the last thing, and probably not the least, is they have to make sure they have trust from the community. That's critical. When you speak as a volcanologist, if you're monitoring a volcano, if you speak, people have to believe that what you're saying. And you have to I didn't get into this, but you have to have a way of expressing to them your own uncertainties without them getting uncertain about your knowing what you're saying and you're really knowing. You understand? So it's challenging, it's difficult, but in the end, if it works, it could be quite rewarding. Thank you very much.
Questions, I would like to say, I think firsthand what work recently has been done, and a lot of times we learn about it because scientists are respected in convention. You ask a local farmer, they'll advise you where to better sample basalts and not basaltic andesite. They know it would be just a farmer. And also the pitch is considered as a hero. And when you mention his name, for instance, a lot of doors will be open for you. But they will also correct you. Says not Richard Robertson, Professor Robertson. Any questions?
Yeah, right. So but what I was saying is that the alert level, the system in Siemens is based on, and for most of the Eastern Caribbean, is based on having this alert level table, which says it will be a table that says it will have some sort of color code or some number, and then it will say what the volcano is doing, and it will say something about perhaps either what the scientists should be doing or what the disaster management agency should be doing. The problem with the ones that we have in the Eastern Caribbean is that it kind of is a generic thing that fits all, it covers all the volcanoes, and each volcano has to be individual. So what we have to do is now work with each individual volcano, given what we understand, and modify that table. In the case of St. Vincent, it was based on the fact that we thought for a long time, the first thing that would happen in St. Vincent, because of the configuration of the crater, was that you would have an explosive eruption. The problem that we have is that that's not the first thing that happened. You had an effusive eruption. And therefore, the table was not designed the system was not designed for the kind of eruption. And you have to be careful when you're doing that. What you have to do, you have to design a system based on your understanding of the volcanic system, as well as what the disaster management agency is capable of doing. So we have to work with them, and we have the table, and the system is going to be modified such that if it's an effusive eruption, there's a different response to if it's an explosive eruption. Yeah. Right. Mm. Yeah. Mm. Well, in a sense, that has always been the case in the Caribbean. In the early days, um, after the 1902 eruption, and in fact, between the 1971 and 79 eruption, there was a system in St. Vincent of essentially volcano watchers. There were people who were employed, and what they did was that they went up to the volcano. They were actually collecting some data also, but one of the key things they did was to observe what was happening. And throughout, when you monitor volcanoes, one of the key aspects of monitoring is actually physical observation. So that has always been and will always be a thing that you do, because no matter how much instrumentation you have, it's very little that you could beat with the human eye just observe it, right? So as it is now, it's kind of built into the system. So the guys who went up were actually part of the local monitoring group that went up to check. And usually how the system works now is that if we see something that we're not sure about, they would physically go and check. Now, what we would like to do is to get into the stage. I think the next stage from that would be to put some cameras in, so that you could check the cameras. And they have done that in a number of observatories and a number of volcano situations. The challenge that you have in some of these situations is that if you put a camera up there, you put any equipment up there. I didn't speak about that a lot, but you have a problem of people going and stealing things. So, you have to balance both of them. But so in answer, I'll say that you can't get away from the volcano watchers, but you can put in things like cameras that could probably duplicate and give you some of that. But I think in the end, for me, I would always want to see whether it is physically going up or seeing it from afar. I cannot monitor a volcano. I find it very difficult to monitor a volcano without seeing it. I had to do it once in Montserrat. And once in Montserrat, we had to move the observatory to the north, and therefore we couldn't see the volcano. And that was one of the most frustrating things, because every time something happens, you see an earthquake, you see something happening, you then have to go and check. And you then have to physically move. The best thing for an observatory, that's why it's called, is to observe. So observation is always going to be critical, no matter how much I think we get into AI and all those things. Human eye, yeah. Unless you have an AI that's better than human eye. I don't know. That's, you have to talk about AI. Yeah, David, sorry. Mm. Yeah. Well, I don't think the challenge that we have is that we have never had it difficult to get engagement. Um, so the challenge that we have is that they will always, okay, there's a recognition in the Caribbean, and I guess in lots of places, hopefully that have volcanoes, that the volcanoes are dangerous, they need to be monitored, we need to take them seriously. But translating that from an administrator saying that to the administrator then giving you funding to do what you need, it's very different. So the interaction I have had with all the islands, and I've spoken to prime ministers up and on the islands, that yes, you guys are doing a fantastic job. You need to keep on doing it. But then when it comes to contributing, they don't necessarily do it. So I think the urgency with which okay, I think they get the message, but I think the urgency with which they then translate that to actual doing something with it is different. So our approach, I think what you need to do is, yes, you need to keep on engaging with them, but I think you also have to get into the people who are electing them. So you need to talk to the communities and get them to see it as important. If they then see it as important, when they come to them to put the X on the paper, they will then tell them, oh, you need to make sure that it's important. And then I think the last thing I'd say is that one of the things that St. Vincent did, and that happens with when eruptions happen. When you actually get an eruption, and if you're administrating, you have to live through the eruption, it makes a big difference to you. So one of the things that the Prime Minister St. Vincent did that was most significant is that soon after the eruption, he then brought a bill in Parliament that makes it mandatory that the government of St. Vincent, whoever the government is, contributes to agencies like seismic. So there's no question, no matter, and that only happens when you feel it. So we'll have to have probably all of them happen an eruption they live through before they actually do that. Yeah, I think the key thing is to listen to people. I think as a researcher and as a monitoring scientist, I've learned a lot from, people talk about, scientists talk about engagement all the time. And I think with some of your funding sources now in the UK, you have to show that you're engaged. Engagement doesn't mean that you go and talk to people and talk to you have to really listen to them. You have to go where they live and understand the things from their perspective. I think if you engage with them and really listen to them, you can actually learn a lot about the science and what has happened that could help you in your science, as well as convincing them of what the message is with them. So I think the key thing is listening to them and going down to speak to them wherever they are and trying to see it from their own perspective. How to see the world. Because you have to see how they see the world for you to be able to change that perspective, for them to see how you see the volcano. Because one of the challenges with volcanoes is often we see as geologists, we could see in 3 dimensions. We could see the history. We could see the volcano at the top, and we could see how it connects down to the below. Most people just see at the top. So their fundamental perspective, it starts from a different space than you. So you have to figure out a way now how you get that. And to do that, you really have to listen and understand where they're coming from.
Obviously, St. Vincent 2021 was a huge success in terms of the collaboration between scientists, the locals, and the way scientists and education happen. So do you have any plans in place how you're going to communicate this experience to other islands like Dominica? We know that unrest now, Guadeloupe, and other islands in the region.
Well, I think we'll just continue to do what I wouldn't say we have any specific plans, but the outreach arm of Seismic have done work in that regard routinely. So what our experience in St. Vincent has now provided a lot of material for outreach in other islands. Ideally, we'd like to replicate some of the stuff that we did in St. Vincent, like the Volcano Ready project, and we're looking for sources of funding for engaging the communities at that level. But some of the materials that we produce, the outreach materials, the videos and the other things, those are going to be used in the other islands in any case. Dominica is one of the places we particularly like to get done for various reasons. Thank you very much.